Hi, everybody. Okay, sorry. So I just wanted to walk through a couple of these last few problems in the 6.5 notes. I think for the most part, what we talked about yesterday should get you through, basically everything through 10 at least. But these last couple, we didn't really get a chance to get to, so I just wanted to mention a couple of things real quick. Um, Remember, the basic idea from what we talked about yesterday is that you want to isolate or solve for the exponential or the log term, and then undo it, right, by using the opposite or the inverse. So if it's an exponential, then rewrite it as a log or take a log. If it's a log, then rewrite it as an exponential or exponentiate both sides, kind of the same idea. Um, and then sort of finish the problem, right? So, excuse me, I'm sorry, I suddenly can't talk. The difference a little bit in these last couple of problems, especially something like 11 and 12, we'll get to the last couple in a minute, but the difference here is that because there are two separate log terms, two or more, that first part where you're solving for it or isolating it, you can't really do that in quite the same way. I can't just like move stuff around and get one of those by itself without the other one, sort of getting in the way. Like here, if I try to solve for this one, then I can't really do the rewriting thing focused on this because this stuff is going to turn out to not really work the way I want it to. So what we need to do instead is use the log properties that we developed in 6.3 on Tuesday, a few days ago anyway, to combine these, right? So what I can do with the log of x plus the log of x squared is turn that into the log of x times x squared. Right, just using that product rule for logs. So in other words, the log of x cubed. Now we have what we're looking for, right? I have a logarithm of a single thing all by itself on one side of the equation. Now we can try to solve. So to solve that, you could either, there are a few different ways you could go here. You could just rewrite it now. Or if I want to kind of think about, again, log properties and like special things that logs can do, sometimes those will help make life a little bit easier. I can take this power and bring it down. So this is 3 times the log of x equals 3. Divide both sides by 3. And we've got that the log of x is equal to 1. What this does that is, kind of nice, apart from just being sort of convenient, is that now when I rewrite, I'm going to be, essentially solving it. Like I'm basically going to be done. This is a log base 10, right? LOG, even though base written means the base is 10. So when I rewrite this, this says 10 to the first, or in other words, 10 is equal to x, and we're done. Another way to do this would have been from right here, the log of x cubed equals 3. I could rewrite it there and say 10 to the third is x cubed, and then take a cube root of both sides. So again, you get x equals 10. Either version of that is fine. Something that's kind of nice about the first way we did it, so this version, is that if that had been a 2 or 4 or something, then when you try to do this, you're talking about a square root or a fourth root. And remember, those kind of behave a little bit differently. Like if you take a square root, you got to pick up a plus or minus, but the plus or minus might not really work in the original problem. We'd have to sort of go back and check because logs have a domain restriction, right? So if you got a negative X value, that doesn't really work. So using these log rules, like I did the first time, sorry, I'm having trouble here. Using the log property like we did here to bring that power out and kind of simplify the thing as far down as we can before we switch it to an exponential is kind of nice because it helps eliminate some of that, I guess, like uncertainty, right? But again, you can always check, and with logs, if you're doing, sort of a lot, right? If it feels like a lot of algebra is happening, then that might not be a bad idea to go back and check solutions. Here, because I got this thing sort of all the way down to this point, so that when I rewrote it, I just get 10. I kind of don't need to do that necessarily, but it's never a bad idea. Okay, so 12 would be a similar sort of deal. The difference there is that you're subtracting. So instead of multiplication, this would be the quotient rule. So this thing would turn into the log base 2 of 4x minus 1 over 13. Sorry, can't keep up with my own color scheme. And then again, you rewrite it from there and finish solving. Okay, so that's something to look out for, especially if you see more than one log term in there. You can use those properties to combine things so that we can sort of do the like isolating or the solving for the log term part that way. Okay, 13 to 14 would be the what if none of that stuff works cases. So here, e to the 2x minus 8 times e to the x. So there are two different exponential terms in here. Again, I can't solve for one without the other side being sort of a mess and kind of throwing things off. But something to notice here is that e to the 2x is the same thing as e to the x squared. And I'm just going to write that like this. So if you look at this thing, what you might notice or might recognize is that these things are the same. So yeah, I'm going to do this thing again. And what we see is that this thing looks an awful lot like a quadratic. In terms of, well, whatever that is. So what I'm going to do is do quadratic things with it. You could either factor or use the quadratic formula. I guess I'll just do it both ways because why not? So to factor, I would need to find two numbers that multiply to 15 and add to -8. Well, 3 and 5 are both factors of 15, and if they're both negative, that would work. So I can factor this. Again, in terms of whatever that is, right? And again, I'm doing the thing where, I'm sort of intentionally not looking at that part yet, just so that I can focus on like the structure, right? So if you want to do the thing where you do like a substitution, like put in a different variable, you could do that. From what I've seen, I don't think many of you, prefer to write it that way, but you could. Or you can just, sort of try to hold off on worrying about the e to the x part for right now. Now, again, you've got a product here that's equal to 0. So the zero product property says that either this thing is 0 or this thing is 0. Which would mean that this is equal to 3 or 5. And then we're kind of at the point where like I've done everything I can while, pretending that that's not there. So I'm going to go back, look at what we're actually dealing with. Again, none of this would have changed from it being e to the x. We're just focusing on the like algebra, right? And the structure of what's going on. So e to the x is 3 or e to the x is 5. Excuse me. Thinking about e to the x as a function, its range is 0 to infinity. So both of those are fine, right? At this point, I would want to be on the lookout for anything where I've got like e to the x equals a negative number or 0, right? Those would not work. But 3 and 5, those are both positive. So that's fine. Like we don't have any weird stuff going on here. And then we would just want to solve those, right? So if e to the x is 3, that means that x is the natural log of 3 or the natural log of 5. And again, there, on the subject of like whether solutions make sense or not, it's a natural log. So you have to be taking the natural log of a positive number. Those are both positive numbers. We're good to go. Excuse me. Sorry. Now, again, if you wanted to, and if you need to copy stuff or whatever, just pause the video because that's how things work. If you wanted to, you could have done this with the quadratic formula instead. I'll just run that real quick. This would be quadratic in terms of e to the x with a equal to 1, b equal to -8, c equal to 15. So when I set up the quadratic formula, -b, so the opposite of b, plus or minus the square root of b squared, 64, minus 4 times a times c would be 60, over 2 times a. And the difference would be that since this is quadratic in terms of e to the x, this isn't x, but it's e to the x. Right? Or again, if you wanted to, do this thing, right? That's what's going on. Okay, and then I would just simplify this 8 plus or minus the square root of 4. So 8 plus or minus 2. So 8 plus 2 is 10. 8 minus 2 is 6. So 5 or 3. So e to the x is 5. E to the x is 3. X is log of 5. X is the log of 3. Would be our two solutions. Okay, so that's the idea there. Again, we're just doing, applying what we know about quadratics and solving them and using the structure of a quadratic to take this thing and sort of break it down to solve. So 14 would be a similar kind of thing. Notice here that this is not the log of x squared. This is the log of x squared, right? So, something like that if you like. So again, you'd use kind of the same idea. Treat this like it's that. So the first thing I would do is move this 7 over to get it set equal to 0. And then try to do quadratic things. I'm going to leave that one there for y'all to finish. That's our Blackboard so you can check solutions and all that kind of thing. If y'all have any questions about anything or need help with anything, please don't hesitate to ask. Otherwise, I hope everything goes well. And yeah, y'all just let me know if you need me. Okay.